All right, guys, in Unit 6, Part 2, we were talking about using the multiplicative inverse to solve equations. So we're talking about fractions here. We're doing multiplicative inverse. So your definition of a multiplicative inverse is that it's just a number's reciprocal. So it's the same thing as reciprocal, except we're going to use this to solve equations with fraction coefficients. Right? So if you look, your directions on the first section, you solve each equation, and each one will contain a fraction somewhere. So first thing we're going to do is same as always when we solve equations, we're going to box and rewrite. Please make sure you're showing all these steps. So I'm going to rewrite this 5 over 8x equals 30. And if you look on the left side, I have a fraction coefficient, a fraction in front of the variable. So we're going to use the multiplicative inverse to solve, or basically the number's reciprocal. So I'm going to take the reciprocal of the coefficient, or the fraction in front of the variable. Now on the left side where the variable is, what that's going to do is cancel everything out. The 8's cancel out, and the 5's cancel out, so I just have an x. On the right side, I'm going to put this over 1. I can reduce first. If it's on the numerator and the denominator, I can reduce. So 30 can be divided by 5, and I get 6. 5 can be divided by 5, and I get 1. So I just need to do 6 times 8, which is 48. And I have my answer there. Now again, to reduce, you have to do a number on the numerator and reduce it by a number on the denominator. Number 2, I'm going to leave to you guys. I'll go over number 3 real quick. Alright, first thing I'm going to do is box and rewrite. So I have negative 24 equals negative 12 over 19x. Okay, only real difference here is that my variable's on the right side. I go to the right side, I want the reciprocal of that fraction, okay, which is still negative, but now just 19 over 12. So if I do it to one side, I have to do it to the other, so negative 19 over 12 multiplied by that over here. So on the right side, the 12's cancel each other out, the 19's cancel each other out, the negatives cancel each other out. So all I have is x. Over on the left side, I'm going to put this over 1. The negatives cancel each other out, so I'm going to have a positive answer. And again, if I have something in the numerator and the denominator that can be reduced, I can do that. So 12 and 24 can both be divided by 12, so this becomes 1. This becomes 2. 19 times 2 is 38. So x would equal 38. All right, looking at number 4. Okay, I'm going to start by boxing and rewriting. So 4 over 7x plus 8 equals 28. So this is a two-step equation because I need to add or subtract first and then multiply. So if you look at the side of the variable, I have a positive 8 over there. I need to move that to the other side, so I'm going to subtract it from both sides. So that's going to leave me with 4 over 7x equaling 20. So now I just have the fraction coefficient and the variable on the left side. So I'm going to multiply by the reciprocal, 7 over 4. Multiply this side by 7 over 4. 7 cancels, 4 cancels, so I just have x. I'm going to write this over 1. Now, 20 and 4 can reduce. 20 divided by 4 is 5. 4 divided by 4 is 1. 5 times 7 gives me 35. So that's my final answer there. Looking at number 5. Erase that mistake real quick. Again, I'm going to start by boxing and rewriting. So I have 6 equals 1 half x minus 1/4. I need to add or subtract first, okay, then divide or multiply. So I have a minus 1/4, so I need to add 1/4 to both sides. Okay, here's the tricky part though. I have a whole number and then I have a fraction. So that's going to give me 6 and 1/4 equals 1 half x. I personally am going to choose to make this into improper fraction because I think it's easier. 4 times 6 plus 1 is 25 over 4. So I'm going to write it like that because I think it makes it easier to solve. I have a fraction coefficient, so I need to multiply by the reciprocal, 2 over 1. Need both sides by 2 over 1. On the right side, everything cancels except for the x. On the left side, 2 divided by 2 is 1, 4 divided by 2 is 2. 1 times 25 is 25 over 2. So that's going to be my answer. Or I could make that a mixed number. It would be 12 and 4. Either way. Alright? 6 I'm going to leave for you guys to do. On the back side of the top, we have a word prompt. It says, the weight of a bull calf is 388 kilograms. If its weight increases at a rate of 1 2/5 kilograms per day, how long will it take the bull calf to reach a weight of 500 kilograms? Alright, so we need to set up an equation to solve this. We're going to start with our goal weight. Our goal weight is to get to 500 kilograms. And our bull calf right now is 388 kilograms. So it says it increases, which I know means is addition, so I'm going to add 1 2/5 kilograms, and it says per day. So that's going to be my variable. So I need to solve this. I need to subtract first before I worry about dividing. So I'm going to subtract 388 from both sides. So that's going to give me 112 equals 1 2/5 x. I'm going to turn 1 2/5 into improper fraction. 5 times 25 plus 2 is 7 x, just because I think that's way easier than dealing with numbers. Now I can solve. I have a fraction coefficient, so I'm going to multiply both sides by its reciprocal, 5 over 7 in this case. So on the right side, 7's cancel, 5's cancel, so I just have x. On the left side, okay, 7 divided by 7 is 1, 112 divided by 7 is 16. And then 5 times 16 is 80. So x equals 80. I know I need some sort of unit. It's asking for how many days. So my answer is 80 days for the bull to reach 500 kilograms. All right, that's it for part 2.